Now let's talk about another way of solving question, which is known as a beggar's method. Now what happens in this type of questions is, let's say you have 4 coins with you and you have to distribute it among 3 beggars. So what are the ways in which you can distribute these 4 coins to 3 beggars? Now of course it is not necessary that each beggar should get 1 coin or not. The point here is that either 2 beggars can get 0 coins and one can get 4. Either one can get 0 and 2 of the beggars they get 2 coins, or 3 1 coins, or 1 3. So all those combinations is what we are trying to find out. So the formula to find out such type of question is similar this one: n plus k minus 1 c k minus 1. So remember this formula. Now of course I hope you all remember, whenever these two numbers are given in brackets, this means n plus k minus 1 c k minus 1. Now let's say if there was a little change in the question. Now what if they said was each and every beggar gets at least 1 coin. So what we are saying is, if each gets at least 1, that means they have to get either 1 or more than 1. Then what would my formula become? My formula would be n minus 1 c k minus 1 simply. Do not mix up both these formulas. The first one, where n plus k minus 1 c k minus 1, is when I am distributing, let's say, more number of objects to less number of people, and there is no criteria as to that each and everyone should receive 1. One can receive 0 also, and one can receive more, all of n number as well. Now when we talk about that each and every person should get at least one of the objects, that time we use this formula n minus 1 c k minus 1. If let's take a look at this example, how many ways can you distribute 10 identical candies among 3 children? Now I have to distribute 10 candies among 3 children. That means now here there has been no condition that each children should get 1 or not. That means I can give all 10 candies to one of the children, or I can give 5 candies to 2 children and 0 candies to 1 children. So those cases are also possible in this. So that time again we use this formula n plus k, where our n is 10 and our k is 3. So n plus k minus 1, this becomes 12 c k minus 1, 12 c2, and this is how we find out the answer. Now this beggar theorem is generally used to find out answers of questions which are in this format, where you have been given an equation, you have been given certain constraints for each and every variable in that equation, and you have to find out the number of integral solutions. Now this is possible only for integral solutions. Keep this in mind. Now here the number of integral solutions to this equation, x plus y plus z is equal to 21. They've given us certain constraints that x is always greater than 1, y is always greater than 3, and z is always greater than 4. Now what we have to do here, first of all, understand we have to divide 21 in 3 different categories. Our n here is 21 and our k here is 3. We have to divide 21 in 3 different categories, and all these 3 categories have some constraints to them, that x should have value 1 or more, y should have value 3 or more, z should have value 4 or more. However, the formula we studied, there was no constraints. That means x, y, z, all 3 should be 0. Can be 0, I mean to say. So how do we convert this equation into that format so that we can use our formula? So what I do is, instead of x, let's say I assume one x dash. This is x minus 1, since x has to be greater than equal to 1. For y dash, I assume it to be y minus 3. And for my z dash, I assume it to be z minus 4. Now I say that x dash plus y dash plus z dash, this should be equal to 21. Now I can distribute this among these 3 variables. Now simply let me just substitute it. What am I going to get? X minus 1 plus y minus 3 plus z minus 4 is equal to 21. From here what do we get? X plus y plus z. This would be equal to 7, 8. So this would become 13. Now I have no constraints for x, y and z. Now I can simply divide 13 in these 3 conditions. So here my n would become 13, my k would become 3, and the number of integral solutions would become 13 plus 3 minus 1, c, 3 minus 1. So from here what do we get? This would become 16 minus 1, 15, 15C2. And what is the value of 15C2? 15 into 14 by 2, which makes it 15 into 7, which becomes 105. This is our answer. So these are the total number of integral solutions in which this equation would be satisfied given these conditions. Had these conditions not been given to us, we could have directly applied the formula with taking n as 21. So keep these things in mind. Now let's talk about finding permutation for circular arrangements. Again, for n arrangements which are in normal linear arrangements, that time we used to say our arrangements would be n factorial, right? Now since they are in a circle, there would be number of arrangements would decrease, because since they are in a circle, the rotation of the circle wouldn't create any new arrangement. The positions in which they are sitting would come out to be same. That is why we use the formula for circular arrangements to be n minus 1 factorial and not n factorial. So exactly that has been mentioned here. In linear arrangements, there are n factorial ways to arrange n objects. In circular arrangements, since rotating the circle does not create a new arrangement, we divide by n, because there are n possible rotations of the same arrangements. So if I have n factorial by n, this can be written as n into n minus 1 factorial upon n. So n and n would get cancelled out and we would be left with this. So that is what has been written here. Now again, the same things that we did for linear. Let's say if I have certain identical objects as well, so I would simply divide it by the number of objects, their factorial that I have. While dividing it, we do not use any minus 1 or anything like that. Simply we divide it by the number of objects that we have. Now since we are talking about circular arrangements, so there can be symmetry as well. That means where if we are considering anti-clockwise and clockwise, that time it would become n minus 1 factorial by 2, because of course if I have n minus 1 factorial ways in which I can arrange n people in a circular arrangement, then they can either be arranged in clockwise direction or anti-clockwise direction, the complete mirror image. So both would have half number of combinations, right? So that is why when we have our symmetry defined, that time we write it our number of ways to be n minus 1 factorial by 2. Now let's look at this question. If 7 women and 7 men are to be seated around a circular table such that there is a man on either side of every woman, then the number of seating arrangements is. So a man should be close to a woman. So that means what I will do first here is I will write my M1. This is my man 1, my man 2, my man 3, my man 4, man 5, man 6 and man 7. So I've arranged them in a circular order. Now these men are not together. That means there is a woman in between as well. So there is a woman here, 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 here and here. Here we have W1, W2, W3, W4, W5, W6 and W7. And of course all these women are different. Now how are we going to first of all arrange our men? Since our men are arranged in a circular order, so it would become 7 minus 1 factorial. This is our arrangement for men. Now for women, since they are in between, it does not matter whether they are in a circle or not, because for men we have already identified that it is a circle. So for women it would directly be 7 factorial. So our answer would become 6 factorial into 7 factorial. This would be our answer. So I hope you are understanding this. First of all, we did not arrange our women into a circle. Our men are only arranged in a circle. And we are putting the women in between. That means our women can have more than n number of permutations as well. That is why for women we use 7 factorial and men 7 minus 1 factorial. Had these been other way around, you could have solved this the other way also. You could have arranged the women first in a circle. That would have been 7 minus 1 factorial. And for men it would have become 7 factorial then. Now let's look at another question. First let's look at this concept. Exponents of prime in n factorial. Now what do we mean by this? Suppose I have, let's say 60 factorial and I have to find out the exponents of prime numbers in this. So I can write down 60 factorial as 2 to the power x, 3 to the power y into 5 to the power z and so on, something, all prime numbers. So because they are getting included in it, right? So what we are doing is we have to find out the exponent of that prime number. So our prime number is p, our exponent is what we are going to find out, and n factorial is the number that is given to us. Now, what is the formula to find out our p? It can simply be, our exponent, it would be n by p plus n by p square plus n by p cube, and this goes on until we get 0. So this, first of all, exponent of p, this is also represented as ep n factorial. So keep this in mind. Now we do this until we get 0. This is my greatest integer function, GIF, greatest integer function. So here, if let's say I have to find out my exponent of 2 in 10 factorial, 2 in 10 factorial. So how can I write it down? How many 2's are getting involved in 10 factorial? If I write down my 10 factorial completely, 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 into 10. I hope you are understanding till here. 2 is 1. Here I have 2 2's. Here I have 1 2. Here I have 3 2's. And here I have 1 2. So if I was to write this in 2 to the power x format, what would my x be? 1 plus 2, 3, 4, 7 and 8. So my x would be 8. Now if I solve this using this formula, what would it become? Factorial 10 by 2 plus 10 by 4 plus 10 by 8 plus 10 by 16. Now of course this value would come out to be 0 since it is a greatest integer function. So here we would have 5, this would become 2, this would become 1. So again we are getting 8 as our answer. So I hope you are understanding this. Now for exponents, if let's say they tell you find out exponents of all prime numbers in this factorial. So you have to identify what are the prime numbers that can come in that factorial and find out their exponents. So apart from that, these things have only been mentioned here. Greatest integer less than or equal to n by p to the power k. The sum continues p to the power k exceeds n. So what does that mean? This means that n is less than p to the power k plus 1 and greater than pk. Why is that? Because of course up till k we are trying to find out, right? Because at k is what is my exponent. At that value my greatest integer function comes out to be 0. That is why we've written it in this format. Again, the same things, the example has been shown here as well. You can have a look at it. For greatest integer function 2.5, it would be 2, 1.25 it would be 1. And at further, there would be 10 by 2 to the power 4, which makes it 10 by 16, which is 0 point something. So it is going to come out to be 0. So that is how we solve our exponent of any prime number in a factorial. Now let's look at this question again, a question that was asked in a previous year JEE Mains, a question of exponent of a prime number 3 in 66 factorial. So we have to basically find out n. So simply we find out exponent of 3 in 66 factorial. Here my n is 66 and my p is 3. So let us find it out. This would become 66 by 3 plus 66 by 9. 3 square would become 9 plus 66 by p cube. This would make it 27 plus 66 by 3 to the power 4. This would make it 81. So here we stop. Since we've gotten this, our denominator to be greater than numerator, this would simply become 0. From here we get 22 plus this would be 7 plus 27 would go this 2 point something times. So our greatest integer function would become 2. So from here what do we get? 31 as our answer. So 31 is the value of n. That means 3 to the power 31 would be a value in 66 factorial. Of course this value is going to be less than 66 factorial. Let's say if I multiply 2 to the power x, 5 to the power y, 7 to the power something, and all these prime numbers that are included up till 66, then I can say that value would be equal. So this is how you solve questions of exponent of p in n factorial. Keep this formula in mind.